Hello and welcome to m253. My name is Lapuz. I'm an instructor for the course, and we are looking at checkpoint 5.40. Here we have a solid Q that's bounded by a plane x plus 2y plus 3z is equal to 6. And then they want that to be the top part of your solid, and then the sides and the bottom would be the other coordinate planes. So I'm looking at this as possibly a tetrahedron in our three-dimensional space, where if I let y and z equal to 0, I'm going to have x is equal to 6. And when I let x and z equal to 0, I'll have 2y is equal to 6, so y is equal to 3. And then when x and y are both equal to 0, I have 3z is equal to 6, so z is equal to 2. So it looks like I'll have a plane that looks like this, and it actually extends in all directions, but we just care about what's happening when it gets cut off by the coordinate planes, the other coordinate planes. So I would imagine that I might be interested in integrating with respect to z first, and with respect to z, I will have a line parallel to the z-axis, and I would imagine that in integrating with respect to z, I will have to go through the plane z is equal to 0, and then z is equal to the plane that's given. And so if I solve for that, I will get z is equal to, it's going to be 6 minus x minus 2y, and I'll divide that all by 3. So I have 6 minus x minus 2y divided by 3, and then that would take care of my three-dimensional part of my surface, or my solid. So now I'm interested in looking at the two dimensions, because now I'm down to x and y. I would have already integrated with respect to z, but now I want to know what's happening on my x and y axis, so I can integrate with respect to x and y. And I'm seeing that there's this plane over here that crosses through when x is equal to 6 and y is equal to 3. That's a line, sorry. And then the shaded region on the xy plane is this, so I want to express this triangular region. That would be equivalent to like setting z is equal to 0 here, and I'm going to have x plus 2y is equal to 6. So I can decide to integrate this with respect to x first, or with respect to y, and I'm looking at x over here like ready to be solved for, so I think I would be interested in calling this a type 2 region, and then integrating with respect to x first. And so I will have x going into the region x is equal to 0, and then getting out of the region when x is equal to 6 minus 2y, because that's this line that you get out of. So we have 6 minus 2y, and then that would leave us with our outer limits being constants, and that's just going to be from 0 to 3. Okay, so we have our bounds for our integral, and it looks like it's going to be a dz dx dy. We could have done this in many different ways, but this is what we're choosing. All right, now to find the total mass. The total mass is going to be given by a formula of the triple integral over whatever solid you're looking at, and the density function dv. So we have our density function we have our Q limits all figured out, so I think we can get this written up. So our mass is going to be the triple integral, and the density function is xy squared z, and our order of integration is dz, where z goes from 0 to this function. I'll call it 1/3 parentheses 6 minus x minus 2y, and then I'll integrate with respect to x. Whoops. Integrate with respect to x, and x is going to go from 0 to 6 minus 2y, and then finally integrate with respect to y from 0 to 3. Okay. So we'll imagine putting that into a calculator program. I believe this should be something that we, well, should be able to integrate, but just to save time, our calculator program actually gives us this this result. So the mass is going to be 54 over 35, approximately 1.5429, and they don't say the units, but it would probably be grams, kilograms, or something like that. Okay, all right, I hope that helps.